You know that bright red star in Orion's shoulder, Betelgeuse? The one everyone's been saying will explode any day now. I have some mind-blowing news about it. Scientists using NASA's Alok instrument on the Gemini North telescope finally saw the companion star that's been puzzling astronomers for 200 years and secretly revolving around Betelgeuse. Here's what you probably heard about Betelgeuse and what I believed too until recently. We thought this massive red supergiant is a solo star, destined to go supernova sometimes in the next 100,000 years. For decades, scientists have been scratching their heads over Betelgeuse's weird behavior. It brightens and dims in these mysterious 6-year cycles that nobody could fully explain. The common thinking, it's just the star pulsating during its supergiant thing as it nears the end of its life. Even during that dramatic great dimming event in 2019 and 20, when Betelgeuse lost over a magnitude of brightness and had everyone thinking it might go supernova. The explanation was simple: dust clouds from the star's own material. But here's where it gets interesting, and where everything you thought you knew gets turned upside down. A team of NASA scientists led by Steve Howell decided to challenge this conventional wisdom. Using cutting-edge spectral imaging technology on the massive 8.1-meter Gemini North telescope in Hawaii, they did something revolutionary. They compared images of Betelgeuse from two crucial moments: during the 2020 Great Dimming, when any companion would be hidden behind the star, and December 2024, when that same companion should be at maximum separation. And voila, they actually detected it. A companion star that's been orbiting Betelgeuse every 6 years, hiding in the glare of its giant partner. Well, I know what you're thinking. Another astronomical discovery that might not pan out. But here's why this one's different, why I'm convinced this is the real deal. First, this isn't some theoretical prediction. These are actual photographs showing the companion star exactly where the map said it should be. 52 milliarc seconds from Betelgeuse, positioned at 115 degrees southeast. The precision is incredible. Second, the detection perfectly explains decades of mysterious observations. Remember those 6-year brightness cycles? They match the companion's orbital period exactly. The radial velocity changes astronomers have been measuring, they align perfectly with gravitational tugging from this orbiting partner. Third, the research comes from NASA's Ames Research Center and has been peer-reviewed and published in the Astrophysical Journal Letters. Steve Howell and his team used the same rigorous techniques that have discovered thousands of exoplanets. Alok can remove distortions in images caused by Earth's atmosphere. This allowed astronomers to see Betelgeuse's faint companion for the first time. But here's the kicker. When they looked at these 2020 images, exactly when the companion should have been hidden behind Betelgeuse, they found nothing. When they looked in 2024, when it should be visible, it was there. That's not coincidence, that's scientific validation. Why take it until 2024 to catch it? The answer is timing and technology. You need to observe at exactly the right moment when the companion reached maximum separation, and you needed cutting-edge spectral imaging to pierce through Betelgeuse's overwhelming brightness. Here's what blew my mind about this stellar companion. We're looking at a star that's 1.6 times the mass of our Sun, but it's orbiting incredibly close to Betelgeuse. To give you perspective, it orbits at only 2.4 times Betelgeuse's radius. If our Sun had a companion this close, it would be orbiting inside Mercury's path. This proximity is exactly why the companion has such a dramatic effect on Betelgeuse's behavior. Remember those mysterious brightness variations that have puzzled scientists since 1836? They're not random pulsations. They're caused by the companion's gravitational dance. As it orbits, it tugs on Betelgeuse's massive atmosphere, creating those regular 6-year cycles we've been observing, those astrometric wobbles that space telescopes detected. There's Betelgeuse being pulled slightly off-center by its partner's gravity. The radial velocity changes. There's the star moving towards and away from us as it responds to its companion's orbital motion. One discovery just solves 3 different astronomical puzzles at once. Here's the most exciting part. When Betelgeuse finally explodes, and it will within the next 100,000 years, this companion completely changes the game. Instead of a symmetrical supernova explosion, you get something far more dramatic. The companion's gravity will warp and channel the explosion, creating asymmetric jets and potentially even more spectacular light shows visible from Earth.